All right, everybody, welcome back. Episode 25 of the MCNA series. And in this episode, we're talking about replacing legacy style transit architectures in the cloud like CSR1000v with next generation enterprise class transits from Aviatrix. This is a discussion around the Aviatrix validated design for migration from those legacy models to the true enterprise class next generation models offered by Aviatrix. As always, I will post a link to the Aviatrix validated design guide that you can follow to get more details after you watch this video. So today we need to discuss, why do we want to migrate away from legacy transit models like the CSR1000v? Why are so many customers coming to Aviatrix on a daily basis asking us to help them migrate off of CSRs and other similar transit architectures? There are all sorts of these legacy models from every vendor you can imagine, and we have all sorts of customers coming to us pleading, please help us make this more enterprise class, please help us automate it, please help us get more visibility and control. So that's what we're going to go through today. We're also going to talk about, what does this next generation transit architecture really look like, right into the details, right in the weeds. And lastly, can this be accomplished, this migration, without affecting the network at whole? How do we do this seamlessly in parallel? We don't want to disrupt the production traffic going across our cloud network, so we have to have a proper method to migrate, and we're going to talk about that as well. So let's get started. So we need to start with the before. Why are these legacy architectures with the CSR1000v operationally expensive, hard to manage, low performing, provide no visibility, etc., right? There's just so many limitations with this one. So let's go through it step by step. But first, the architecture is pretty basic. You have a transit VPC, and in that transit VPC, you manually insert and configure and manage a couple CSRs. Now, these CSRs connect upstream to your VPCs and your resources through IPsec tunnels terminated on VGWs in each VPC where the workloads live. And then on top of that, we run BGP. All right, so you can scale this out, and the more of these you have, the more, of course, difficult this is to manage, because at this point, you're really a glorified network cabler for the cloud. You're configuring and managing and manually instantiating VPN tunnels, BGP peerings, routing policies, CLI configuration, everything via CLI. There's no centralized management in this type of architecture. Downstream, you connect to on-prem through either IPsec VPNs with BGP on top, or you can leverage direct connects or express routes depending on whatever cloud you're in. Challenge number one that our customers bring to us on a daily basis is that they're tired of managing the complexity that exists in this type of architecture. These CSRs are managed device by device, discrete configuration files, all via a legacy CLI. There's a lot of functionality that's been thrown into the CSR over the years, stuff that isn't even relevant to the cloud. And so it's complex to configure, it's complex to monitor, it's complex to manage after the fact. To make it a little bit easier, they've then leveraged things like Lambda scripts to pull the status of components in the network, to look at tags, to create IPsec tunnels and tie them to the right environment and do the routing. But it's super complex and it's hard to manage. It's not intelligent. It's not like an active function. It's a very static scripting mechanism that has no intelligence and is a pain to scale out, a pain to manage. They're just tired of it. We can't go down this path any longer. This isn't 1990. We live in a modern world. We need a modern solution that's cloud scale, cloud native, that does all of this management from a centralized, superior controller-based model. Everything in networking has gone that way over the last 10 years, and we can't keep applying legacy mechanisms to new solutions being offered to us in the cloud. Okay, so that's number one. No more of this box-by-box discrete management. Nobody wants to manage a bunch of IPsec tunnels and BGP connections and BGP policies, routing policies, VRFs, and nobody wants to have to do any troubleshooting via a CLI. We don't need to have a bunch of people on staff who have in-depth knowledge of routing and Cisco and all that stuff, right? It's just, we need to be moving at a rapid pace, and this is holding us back. Challenge number 2 is around automation. Earlier, I briefly mentioned these two things here, the VGW Polar and the Cisco Configurator. These are AWS Lambda scripts. Basically, over time, people needed a way to make this a little easier to manage because it was such a mess of tunnels and routing, and it was very manual and static, very hard to handle at scale. And so this was an attempt to add a little bit of automation to the whole setup, and it is still very static. It's not very intelligent, not very flexible. It's not a great way to do this. It's just very basic way to do automation compared to a real controller based solution with a lot of logic that's been injected into the controller over many years of development. And so this is really not the right way to do this at scale. It's still complex, it's still difficult to manage. It's not an efficient method for automation of a transit or even a networking infrastructure in the cloud. What you really need are two things: a more intelligent centralized controller automation model, and you need a multi-cloud supported declarative scripting language automation tool called Terraform. Terraform by HashiCorp is an incredibly powerful yet simple automation function for cloud networking. It makes automation so easy to consume and integrate into your existing CI/CD pipeline. And so really you just have to spend a little bit of time to understand Terraform scripting, which is so basic. Anybody can pick it up within a couple hours and you're off to the races. It's incredible what you can do with Terraform and how you can build out massive, scalable, highly available and high performing networks in the cloud with Terraform in minutes instead of hours or days. Highly recommend you go look into Terraform and how Aviatrix works with Terraform. Aviatrix is actually an official Terraform provider. We work directly with HashiCorp, and we have all sorts of documentation, training, step-by-step guides on how to leverage Terraform to make a really powerful next-generation automated network for the cloud. We even have modules, which are abstractions of scripting complexity that make it as simple as copying and pasting a module per use case. Let's say you want to build out a transit in region A and a transit in region B, and then copy that to another cloud, and then connect all that to on-prem, and then connect all your VPCs and VNets, and then add firewalls into the path of traffic. You can do all that in minutes. No joke, it's unbelievable. All right, next challenge that our customers present us with is around visibility. You can spend all this time building this beautiful network. I don't care how you build it, whether it's through, well, I do care. I'd rather you build it through an intelligent mechanism like Aviatrix, but you can spend all this time building this beautiful network through your own do-it-yourself ideas or however you want to do it. But building is day one, right? You build a couple times here and there. You might build once in a while, but you're not building all day long. You're operating all day long. You need the right tools to be able to efficiently manage whatever you build, and you don't get that with this legacy architecture. You get show outputs, show IP route, right? Or show IPsec SA, whatever it is, all these commands, all these show outputs with no true interaction, no feedback, no analytics, no true tooling that's cloud native to give you the information you need to quickly do troubleshooting or post-mortem or reports for the business, whatever it might be. You just don't get it with this. You have to use all sorts of third-party tools and add more complexity to your already super complex legacy network, right? It's just, we got to stop wasting your time with these legacy architectures because you're not going to get any with it. If you keep trying to do it yourself all day long, all you're going to build is this ridiculously complex environment that only you and your buddies know, and that is doing nothing for your organization. Let's be intelligent about this going forward. So with this architecture, what visibility do you get? There's no centralized visibility dashboard. You're not able to detect packet loss and latency and end-to-end path detection for your applications and how applications are performing, right? You're not getting any of that visibility. You don't get network throughput reports. You don't get a centralized alerting model. You don't get in-depth packet views and packet capture. You don't get all this stuff that you're supposed to have, where you're supposed to have it, in and out of every VPC, in and out of the transit, towards services, towards the on-prem. You don't get any of that, right? It's all do-it-yourself. It's not a built-in model. Again, back to hard to manage, additional complexity. Okay, let's get a little more technical and talk about something like performance. These legacy transit architectures offered by Cisco CSRs or Palo Altos or whatever you have out there that was a legacy model have never really been known for their good encrypted throughput, right? They've actually been pretty lackluster. Like the CSRs, they've been stuck at 5 gig, 6 gig, maybe if you're lucky, 8 gig for the longest time. And other solutions have really capped out at around 10 gig. That is creating a bottleneck for your infrastructure here. A lot of customers have built a bottleneck in the cloud. The transit should never be a bottleneck. It shouldn't be a limitation. This is the most important part of your cloud networking infrastructure. It's the heart of the network. You got to build that out to be super robust, super high performing, super highly available. Otherwise, you're going to be in trouble. I guarantee it. So in this design, these CSRs, they're really capping the traffic out. Whether it's east, west, north, south, or out to the internet, traffic has to pass through them, and performance is going to be limited. Not only that, the VGWs over here that these tunnels and BGP is being terminated on, they are going to cause a problem from a performance perspective as well, because they don't support equal cost multipath routing. Only one of these links, one of these paths can be active at any one time. And so now that tunnel that you've terminated that's active is going to be limited to 1.25 gigabits per second. So your whole VPC in and out of it is going to be limited to 1.25 gig. That is, that's so basic of a throughput level these days. All of our customers are demanding way more than that. So it's just not going to work, right, going forward. We need some new model. When it comes to connecting to on-prem, you can terminate these 10 gig unencrypted direct connects, for example, into your legacy transit model. But what happens when you want to encrypt downstream, whether it's over the internet, a high throughput internet connection, maybe a private peering connection, or a direct connect or express route? Now what? Well, you're back to the 1.25 gig. You're encrypting at a very low rate. Painful, definitely not going to work for the majority of customers out there today. Another common technical problem that customers bring us that they're facing with this architecture is that those VGWs over here, they don't support many routes. It's like 100 or so, and you can maybe raise it to a little bit more, but the truth of the matter here is that they're basic constructs that don't support many routes. The moment you go above a certain route limit, like let's say you go from 100 to 101, BGP flaps, traffic is impacted, things go down. 100 routes, that's pretty basic. What if you need more specific routes? What if you haven't summarized appropriately? What if you just have to have that flexibility of additional routing in and out of your VPCs or your transit? Well, you're kind of out of luck here. The other option is you could throw a CSR in every single VPC and in the transit, and now you have a high route table limit, but that gets to be super expensive. And my God, try managing a bunch of CSRs within every single VPC, trying to make them active. It's possible, but man, your life is going to be hell. So you got to really think carefully about that. Route table limitation, it's a real problem. We hear about it all the time. And last challenge, but definitely not the least challenge brought up to Aviatrix Solutions architects and SCs, is around service insertion, especially next generation firewall insertion or load balancer insertion or SSL decryption insertion. Inserting services in the path of traffic is very difficult, very manual in a legacy architecture. It's basically hand built, DIY, no intelligence, no automation, no understanding of the cloud native functionality. These CSRs or Palo Altos, whatever you have in there doing your legacy routing today, have no understanding they're in the cloud. They don't know. They're just a legacy model that's been replatformed for the cloud, and now they can operate as an AMI or whatever, right, in your cloud environment. But they really don't understand what's happening under the covers. So they don't know how to insert an additional firewall service or load balancer service into the path of traffic dynamically and manage and monitor the life cycle of it, make sure it's healthy, make sure you're keeping state, everything is symmetric, you're not losing visibility through NAT and things like that. So there's really, you can do it, you can insert firewalls, don't get me wrong, but again, it's just more complexity, lower scale, less visibility, less optimal. It's taking the hard path with very little benefits when you could take the easy path and get a ton of benefits, right? It's a no-brainer at this point. Nobody should be manually inserting firewalls and manually adjusting routing and all that stuff these days. It's just, you're wasting your time. So what do customers do to get around all these issues in this legacy architecture? Well, they obviously move towards a more intelligent architecture, the Aviatrix multi-cloud networking platform. You'll see by the end of this video how much of a no-brainer it is to move to something more intelligent so that you can stop wasting your time on remedial tasks in the cloud and focus on building something better for your organization so that it can move forward and be successful in the market. So I want to start just real quick by highlighting the core components of the platform. So number one, we have the Aviatrix controller. Of course, that's the heart of the whole solution. That's the brains. That's the control plane. That's the UI, and that's also the automation target for Terraform. So you Terraform against the controller, and the controller figures out all the complexity behind the scenes across all your clouds to deploy whatever you're trying to deploy. The controller doesn't affect the data plane. Controller can go down. Nothing happens to your data plane. It's there to monitor, it's there to configure, it's there to manage the infrastructure. Of course, the controller can be designed to be HA, no problem. The second component of the Aviatrix platform are the data plane gateways. These are just instances that get spun up by the controller and placed strategically throughout your multi-cloud network. And so if the controller spins up a transit network and a transit set of gateways, then these gateways get instantiated with transit functionality. If the controller spins up gateways in your VPCs where your workloads live and connect them back to your transit, well, those are spoke gateways and they have spoke features. Or maybe you're doing firewall insertion, well, that would spin up FireNet gateways to load balance across your firewalls. Lastly, we have Aviatrix Copilot, which is our visibility platform. Copilot is talking to the controller, to the gateways, to the cloud native constructs to gather all the information it needs to present you easily digestible outputs, whether those are topologies that are dynamic with visual troubleshooting tools built in, or they are traffic analytics, flow reports, app end-to-end performance reports, latency reports, notifications, performance data, whatever it might be, it's going to gather it all and make it easy to consume as a user of the cloud. Let's start talking about solutions. What is Aviatrix doing to solve all of these problems that our customers have brought us from legacy architectures? Aviatrix has spent the last 6 years solving the most complex cloud and multi-cloud challenges out there. We have the most experience out of any organization in the world. We have a solution for every single problem you're going to face, every challenge that you will face in the cloud. I guarantee it. Talk to our solution architects. We always have a solution. I have never seen a single problem that we haven't been able to solve. And then we take all that intelligence, all those lessons learned, and inject them into the logic of the Aviatrix controller. So the controller just keeps getting smarter and smarter and smarter with every release. Let's start with the build process and the operations behind that. With Aviatrix, you're no longer going to build anything manually. All of the tedious tasks are automated and orchestrated intelligently in the right order with state. Everything is built via the Aviatrix UI or through Terraform automation coded against the controller. So as you're building out the network, you might do a couple clicks here and there, some drop downs, fill in the blank, give it some information, whether that's a Terraform script or in the UI. But behind the scenes, Aviatrix is going to do 30, 40, 50 plus API calls and processes across the clouds to build out that network perfectly, to make sure it's highly available, highly scalable, with high performance every single time. So the end user is saving a ton of time. They don't have to worry about all the ridiculous things they had to in the past. It's all done for you by the controller. Remember, with Aviatrix, there's no device-by-device configuration or legacy CLI to manage and configure with. The controller is what spins up the data plane for you and does all the connectivity, all the routing, all the propagation of routes, all the control plane mechanisms, all the IPsec management, everything for you. All you have to do is a couple clicks, a couple drop downs, or maybe a couple pieces of a script, and you're ready to rock and roll. The best part is that the controller is monitoring and keeping state of what you built. It's watching what you've built and ensuring that you have network correctness as you build out. It's going to make sure you don't have routing loops. It's going to make sure you have the most optimal and efficient path in and out of the cloud or between clouds. It's going to make sure you don't cause overlapping CIDR problems. It's really smart. It's going to keep you on track with guardrails. The best part is that you'll always be adhering to a validated best practice architecture that's been validated by hundreds and hundreds of customers across every single vertical. Now, we also solve the automation problem that customers are experiencing with legacy architectures. You don't have to worry about those complex, static, inflexible Lambda scripting mechanisms anymore. You have a multi-cloud scripting architecture through Terraform. This is the de facto standard now for automation in the cloud. HashiCorp knows what they are doing. And we are strongly and closely partnered with Terraform as an official Terraform provider. Anything you need from a documentation perspective, how to run, how to deploy with Terraform, we have it all on the Terraform website and on our website. All you got to do is follow the instructions, read the documentation, deploy some modules, copy and paste this and that, create some variables. Really, it's pretty straightforward. Anybody can pick it up. Once you figure out the whole Terraform thing, it's so easy now to integrate this into your existing CI/CD pipeline that your DevOps teams are probably already building for the application portions of your cloud. Now you can have them integrate the networking infrastructure as well using the Aviatrix Terraform provider. Another benefit of the Aviatrix Terraform provider is that you now only have one provider to leverage to build things. So you just use the Aviatrix Terraform provider and we'll handle the automation and build it across multiple clouds and multiple vendors for security, firewall insertion, for example. Just one Terraform provider will do it all. Unified API, save a lot of time. Let's talk a little bit about visibility before we jump into the weeds here. After you've built out this really nice network using the Aviatrix controller via the UI or Terraform, you need a way to monitor and visualize exactly what you're building, how data is flowing, what's the performance of the network, and all the tools you need to see the health of the environment. Aviatrix Copilot is what's doing that for us. As I mentioned before, Aviatrix Copilot is ingesting all sorts of data from the controller, from the data plane nodes, the gateways over here, as well as the native constructs of the cloud CSPs. It then gives you easily digestible outputs to visualize what's happening. For example, what's my current topology look like in real time? Visual troubleshooting tools like ping and traceroute and other things like packet capture. On top of that, we're going to give you real-time latency data, so you know exactly what the latency is within cloud, across region, and across cloud. We also have flow analytics. So because we have our own network, we have our own data plane that we're managing, we can export NetFlow v9 data as traffic passes the Aviatrix overlay. NetFlow v9 gives us all sorts of granular details around traffic passing through the network, so we can go dive really deep and get exactly the data we need. We can build dynamic filters, we can focus on certain areas of the network, we can see bandwidth utilization, trending top talkers, flow analytics around Sankey charts, geolocation, and even the most detailed flow outputs right down to the nitty-gritty. Okay, so everything you need from a flow perspective built into the Aviatrix platform. Now, from a monitoring perspective, we're going to give you all the details about the performance of the network, whether that's latency reports or CPU utilization or memory utilization or throughput on all the data plane nodes. You can alert on any of it with the notification functionality. And if you're an organization that does a lot of connectivity downstream via VPNs or BGP connectivity, we're going to give you status on those VPNs, the details of those VPNs, the details of the BGP peerings, as well as routes that are learned, routes that are advertised, a nice BGP map so you can see quickly what's up, what's down, how things are connected to each other. It's brilliant. It's a really nice way to visualize really quickly what's the status of your networking in the cloud. Lastly, we can do app-to-app testing and reporting. We'll tell you exactly what path that app is taking to get to another resource. What's the latency end-to-end? What's the gateway performance end-to-end? Network analytics on those flows. And we ensure that the path is actually able to take place by looking right into the native cloud constructs to ensure that they've been configured correctly to pass that traffic. Now let's get into some of the technical stuff. Performance. Performance is key for every single customer. Remember, I said no enterprise solution should ever be a performance bottleneck for your organization. And we take that to heart seriously. Aviatrix doesn't have these encryption limits that you see in the industry today. We've alleviated all that. We're way above that. Our encrypted transit architecture can reach speeds of 75 gigabits per second, and even in some cases we've tested higher than that. And as CSPs bring more powerful compute into their infrastructure, our encryption just keeps getting better. So everything is encrypted, of course, end to end, but at high throughput and very low latency. So whether you're going from spoke to spoke, spoke to transit, transit to another transit in a different region, or transit to another cloud, we're making sure we're always hitting the peak encryption rate possible. We can even encrypt to on-prem over a direct connect or express route or private line or over the internet at line rate. So high throughput connectivity and encryption, we've got that covered. Now, since you own your own data plane by leveraging Aviatrix, we eliminate the route table size limitation problem that our customers face. You don't have to worry about this anymore because Aviatrix gateways can handle thousands and thousands of routes and can reconverge on thousands and thousands of routes. Not an issue anymore. On top of that, we have all sorts of mechanisms to summarize and to ensure that we never overload a spoke VPC routing table with routes. Now, not really around performance, but more so around intelligence, I want to talk about how the controller can enable more advanced enterprise functionality when it comes to the control plane and routing. Aviatrix controller acts as the centralized brain, the routing decision maker for the entire Aviatrix overlay. So the Aviatrix controller receives and learns about all these routes, whether it's from BGP or attachments or manual insertion of routes, whatever it might be. The controller learns about them, does its path selection algorithm, makes a decision, and then programs the routes across the gateways and VPCs and VNets, etc. appropriately. It also handles route filtering to make sure that you can filter where appropriate and you're not learning and propagating routes that you shouldn't be. Now, we can do advanced traffic engineering as well. You can manipulate how routes are advertised, where summarization occurs. We can even make decisions based off AS path and BGP med. We can manipulate the AS path as it gets advertised to our neighbors. The control plane looks at med and AS path as a part of its decision-making process. And it can even carry BGP metadata end to end. So the AS path, as an example, can be carried end to end, and it can be added on top of each other so that there's a proper understanding of what the path was for that particular route. Now let's talk about security and security insertion. For example, segmentation, multi-cloud segmentation. Executing proper segmentation in the cloud is really difficult if you don't own the data plane end to end. It's nearly impossible, especially multi-cloud segmentation. It's very hard to implement, hard to control and manage, hard to scale, and you have no visibility. It's a very inefficient process. But with Aviatrix, because you own the data plane end to end, you can leverage the Aviatrix segmentation model. It's a multi-cloud model where you can have the same segmentation policy working across all clouds. So for example, you could take this VPC over here and you could put it in its own segment, and this VPC over here could be in a different segment. Just give it different segment names and they can't talk to each other anymore, kind of like a VRF. They could talk to on-prem and they could talk to other VPCs in their same segment, but they can't talk to each other. It's as simple as a connection policy in the UI. In a couple seconds, you've created segmentation across the cloud. Now, what if you wanted a shared environment? Well, like over here, put this in a shared segment, create the policy that says these two segments can talk to this segment, and bam, the routing, all the policies configured for you to ensure that these two segments can talk to the shared segment, but they can't talk to each other. As simple as that, and it works across all clouds. Now, what about inserting firewalls? Earlier I mentioned how difficult and painful and how inefficient it is to manually insert next generation firewall appliances into your path of traffic. And it's true. Doing it yourself, DIY, or even with these legacy architectures it's very hard, right? Don't waste your time trying to do that. Aviatrix has solved this in partnership with the clouds, in partnership with the next generation firewall providers. We understand and speak the APIs of the cloud as well as the APIs of the firewall, so we can control the entire process. We will spin up, as a part of a workflow, firewalls in a redundant, highly scalable fashion and load share traffic based on your policy to be inspected by those firewalls. We'll ensure that the traffic is kept symmetric, state is kept. We'll spin up the firewalls, we'll handle the life cycle of them, we'll make sure that they're healthy, and if they're not, we'll pull them out of the path of traffic, we'll put them back in. We can scale out to 20 firewalls per VPC, and we can have multiple VPCs that act as security insertion points for your cloud network. So throughput and performance and visibility and state is never a problem with Aviatrix. We handle it all for you. Really, you can insert anything you want. It doesn't have to be a firewall. You can put anything there you want as long as it's a layer 3 appliance that runs in the cloud and can be put into the same VPC as our transit. We can manage and monitor and push traffic to them. Now, I've only touched on a small portion of the functionality and benefits that an Aviatrix multi-cloud networking platform can bring your cloud infrastructure, go read the actual AVD, Aviatrix Validated Design Guide, and learn a lot more about what we can offer from the perspective of automation and control and visibility and security. There's so much more in this platform than I can actually put into one video. And if you want to learn more, actually, you can go watch all my other videos. I talk about every single thing and I deploy them all for you in real time. It's really, really fun to watch. But it's important to note that Aviatrix was built in the cloud from ground up to be cloud aware. This isn't a model that we've had on-prem or some legacy architecture, legacy software that we've re-platformed for the cloud. No, this platform from day one was designed to work in unison with the cloud at cloud scale. So it truly understands what's happening in the cloud, all the cloud constructs, all the mechanisms that exist in the cloud. It understands them all so that your experience is seamless, so that you can easily integrate new features that come out and leverage them for your infrastructure. Okay, so let's say that you understand everything I talked about, you truly realize the value of this platform, you're bought into it, and you're ready to deploy. What does it look like after you've deployed? Well, it looks like this. Here's an example of a single region Aviatrix Transit architecture. You have a transit VPC with your Aviatrix Transit gateways in there. They connect to all your workload VPCs with spoke gateways. All the segments are built out, all the routing is done for you. You have these different domains for security. Downstream, you're connecting to on-prem via Direct Connect or a VPN. Maybe you're connecting to some partners. Maybe you're connecting to some users via user VPN. Maybe you even have an SD-WAN environment that you want to connect into Aviatrix. Well, we have models for that. We have validated designs to connect any SD-WAN into Aviatrix. It's awesome. And then let's say you want to take a step further. You want to make this a multi-region and multi-cloud. Here it is. You can see now we have an AWS, and this could be single region or multi-region. We have the same infrastructure built out in Azure and in Google Cloud, and they all connect to each other in a full mesh, a high throughput, low latency, full mesh. All the routing across all the clouds is done for you through the Aviatrix control plane. You don't have to touch a single thing, and everything connects down on-prem. The best paths are selected. You can manipulate them. It's amazing. You can go from one cloud to another cloud in 5 minutes. I'm not even playing this up. This is true. In 5 minutes, you can deploy another transit, connect them to each other, connect the VPCs and VNets and whatever to the transits, and bam, you're running and everything can talk to each other. The security model is still retained across clouds. The architecture follows the best practice, and you're doing something more valuable with your time now. The last thing I need to talk about is how to migrate from these legacy transit architectures to the next generation enterprise class Aviatrix Transit architecture. It's actually pretty straightforward, and we have a whole professional services organization that can step you through it and help you with it if you have a really complex environment. But for most customers, it's pretty straightforward. And if you read the AVD, you can see here that we have it laid out in steps. Number one, we plan the migration. Of course, you need to figure out what's the state of the network, what's it look like now, what's it going to look like after, figure out your CIDRs, your route tables, security groups, understand all that first, right? Then you deploy an Aviatrix controller and a transit hub. You can do that in 30 minutes. No joke, you can spin up the controller via CloudFormation or Terraform in 20 minutes, and then the transit hub in 5 minutes, and you're ready to go there, okay? Then you deploy the gateways in each VPC or VNet where your workloads live. Then you build some duplicate route tables in each spoke VPC or VNet so that we can leverage those for migration, right? So we can ensure that the Aviatrix environment and the legacy CSR environment can work in parallel for now until we migrate. Then we attach the spoke gateways to the Aviatrix Transit Hub. Once you're ready to migrate, you disengage the CSR connections by changing the subnet associations where your workloads live to the Aviatrix managed route tables. So now where your workloads live, they're gonna follow the route tables that go to the Aviatrix spokes that then send it to the Aviatrix transits. As simple as that. Then you can transfer any direct connects or express routes to the Aviatrix transit as well, and then you can tear down your old environment. If you need help with this, just reach out to us at info@aviatrix.com. We can step you through it with our professional services organization. And that's it. I really hope you were able to realize the value of this incredible platform and you see how it could save you time, save you money, make your network more intelligent and powerful, and help your organization succeed in this competitive market. We're here to help you. Reach out to us if you have any questions. I look forward to speaking to you all in the next one. Take care.